Hi everyone!
Hi!
Today we're going to be learning about mental maths. I told you about that yesterday, not appropriate. Off you go. Mental meaning you're solving it in your mind. And today we're looking at subtraction. Now if you're a parent watching this is going to be ever so useful for you, especially if you went to school in the 60s, 70s, 80s. You're probably not going to be familiar with the number line method, but your children will know it, and it's extremely powerful for teaching children how to add up in their heads. So parents, this video is very much as much for you as it is for your children. If you watch this one, you get a lot out of it. Your children know this method, so you really need to know about it too if you're going to be able to help them with their maths. To be really good at maths, it's best not to just rely on one strategy for things, but have a whole host of strategies at your disposal, and it makes you a much more fluent and a much better mathematician. But before we get started, there's something else that I need to say. To be good at subtraction, you need to really be very fluent with your number bonds. So if you haven't seen my video on number bonds yet, then head back and watch that one first. If you are very fluent with your number bonds to 10, that's going to really help you today. The other thing you need to be aware of is subtraction and addition are very, very closely related. They're opposites of each other. In maths terms, we call that the inverse. You can work one out by using the other. In other words, you can work out subtraction questions by using adding. For example, if you know that 2 add 3 is 5, then you know that 5 take away 3 is 2, and that 5 take away 2 is 3. So if you've not seen my lesson on how to add in your head, then I would watch that one first, because that's really going to help you to connect adding with subtraction and then see how the two fit together really, really well. But that's enough from me. Let's have a look at some brain teasers to get us started. Here we go. Mr. Podge has 10 pence. He buys a cake for 7 pence. How much money does he have left? Mr. Podge, you can't have your cake and eat it. Apparently you can. Mimi the mime artist has £1. He buys a balloon for 67 pence. How much money does Mimi the mime artist have left? Apparently none, but then he is a mime artist. What can you expect? Bugsy has £9,020 in his dodgy suitcase. He wants to buy a water pistol for £40. How much money will he have left in his dodgy suitcase once he's bought the water pistol? He definitely looks very dodgy. It's the moustache that gives it away. So, as always, I want you to have a go at solving these problems first before I give you the solutions for them. Something very important to say here. To be good at maths, you have to practice doing maths. You can't just be good at maths by watching maths. It's like riding a bike. You can't learn how to ride a bike by watching someone else ride a bike. So with these videos, don't just watch me do maths. Actually practice what I show you. Secondly, have a go at all of these questions today, because each of these questions use a slightly different method, and it's learning the different methods that will make you a better mathematician, rather than just skipping to the most difficult question all the time. If you are already very fluent with your number bonds, then you probably don't need to have a go at the green section, but definitely do the blue and definitely do the red, no matter how advanced a mathematician you are. If you're in year 1 or 2, you might want to stick to the green, but have a look at the blue as well, see how you get on. There's something else that I really need to mention here as well, because I'm not sure that you're all aware of it. In my videos, after we have explained the initial problem, I always then have a set of questions for you to answer and practice. And that's a very, very, very important part of the video. So if you're not aware of that, you need to fast forward through the green, blue and red solution to the next section where I give you some problems to solve. Today I'll put on the screen a time code so you can see where that bit is. So after you've had a look at my solutions, you can skip to the correct time code and have a look at the problems and have a go at doing them yourselves. Again, I cannot emphasize enough that it's practice that makes perfect. So practice the questions that I'm going to give you afterwards. But for now, Mr. Podge is going to come on and do some comedy dances. Pause it at any moment. Go off, solve the problem, use apparatus, do drawings, do calculations, whatever. Do your best to solve the problems, and then when you're done, or you've got as far as you can go, hit play, and we'll have a look at some of the solutions. Some of the solutions might surprise you today. You might have particular ways that you like to do things, but today I'm going to show you that sometimes there's another way which might be quicker, and it really depends on the question as to which method you should use. Okay, over to Mr. Podge, and I'll see you in a bit. As always, the green section will be answered with the green pen, the blue section with the blue pen, and the red section with the red pen, so you can fast forward to the section that you want to see. Let's have a look at the greens first. So Mr. Podge had 10 pence, and he wanted to buy something for 7 pence. How much money will he have left? There's all sorts of ways that you can do this using apparatus. So the first thing is we could look at a bead string with 10 beads. There's 10 beads. We can take away 7. 1, 2, 3, 4, 5, 6, 7. And we can see that we're left with 3. 1, 2, 3. So one thing you can do to help you is get a bead string. You could also use coins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we take away 7. 1, 2, 3, 4, 5, 6, 7. And you can see that there are 3 left. You could also see this using a part whole diagram, where you draw 1 bar to represent the full number, in this example 10, and then you draw 2 bars underneath to show that 10 can be made up of 3 and 7. So 10 take away 7 is 3. It is also very worth looking at my video on number bonds, which will give you some very useful hints and tips on how to memorize numbers that add together to make 10, which is very, very useful for subtraction. You should aim to memorize all of these facts. Because that is going to help make your calculation much more fluent. If you know the answers off by heart, rather than having to work them out, you're obviously going to be faster at calculating. So Mimi the mime artist had £1, and he spent something which cost 67 pence. How much money did he have left? Now, first of all, we have to realise that this is actually a subtraction question, a takeaway question. And we can see that by representing this in a diagram. This is called a bar model. The money he has to start with is £1. He spends 67 pence. And so this amount will be what he has left. The amount he spends plus what he has left has to equal the money he started with, or the money he started with, take away what he spent, will tell us what he has left. Now you may have tried to start solving it using what we call column subtraction, which you may have learnt. And you can do it this way, but it's a little bit complicated because there's lots of exchanging that you need to do. And I'm going to be doing a video in a few lessons' time on this method, so I'm not going to cover this now. I'm just going to say for this type of question, this probably isn't the best method to use. One thing you could use to see how to do it very easily is a bead string. There's 100 beads, so if we pretend this is worth £1, then each of these beads will be worth 1 pence. So we have £1 and we're taking away 67 pence. So that's 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67. We take them away. What are we left with? 10, 20, 30, 31, 32, 33 pence. We can also show that calculation on a number line. it would look like this. We start at the amount that we took away. So we've already counted all the way up to 67 to this point on the bead string. We then need to count up to £1 or 100 pence. We can do that by using our number bonds. The next multiple of 10 would be 70. So if we add 3 onto 7, which brings us up to the next 10, that's a very easy calculation to do in our heads. And then we can use our number bonds to 10 again. Actually, in this case, our number bonds to 100. We're going from 70 pence up to 100 pence. Remember, £1 is the same as 100 pence. What do we add to 70 to give us 100? We add 30. If you don't know that fact, then head back to my video on number bonds. It's very important that you know your number bonds to 10 and 100, which will help you be much more fluent with this type of calculation. But here we can see we added 3 and then we added 30 to get to our number. So the answer is 33. So a column method is not always the best method for solving a problem. It depends what the problem is. For our red brain teaser today, Bugsy had £9,020 and he bought a water pistol for £40. First of all, we have to realise that this is a subtraction question, and we can represent the question with a bar model, where we write the largest number in the bar, we put another bar underneath to show the amount that we're taking away, and the final bar represents how much money we will have left at the end. Our original amount, take away the small amount, will equal this amount. Also, this number added to this number should give us our total number of money that we started with. Now you may have tried to do this using a column method, which I'm sure you're familiar with. But actually the column method isn't always the best method to use. In this question, for example, it's quite tricky to do it this way because there's lots of exchanging to do. And I will cover the method of column subtraction in a few lessons' time, but I'm not going to talk about it now because for this question, there's an easier way of doing it. And that is to use a number line. Now, in our previous example, in our blue example, we started with the amount we had taken away and we counted on to our final number. You could use a similar approach here. And we would add on in stages until we get to our number. However, with a number line, it's not only possible to count on, but it's also possible to count back. And when you are taking away a small number relative to the number you're starting with, it's actually better to count back than it is to count on. So in order to do this, all we have to do is take away 20 to get to 9,000, and then take away another 20 so that we're taking away 40 altogether, and that will give us our answer. And we can use our number bonds now to work out 9,000 take away 20, and that will leave us with 8,980. So now you've seen various different ways that you can solve subtraction questions, then have a go at these questions. We've got green, blue and red, easy, medium and hard. And again, it's good to have a go at all of the questions today because they all use slightly different methods. If you're very good at your number bonds already, then maybe just do the blue and red section, but definitely do both those sections today, no matter how good you are at maths. If you're in year 1 or 2, you might just want to do the green section today, but have a look at the blue section as well if you want to. See how you get on. Meanwhile, Mimi the comedy mime artist is going to do some comedy mimes for you. Pause at any moment, head off, actually do the questions, solve the questions, you know the importance of that, actually having a go yourself, and then come back, hit play, and I'll give you the answers for them. So hopefully you've had a go at doing those questions. Now let's have a look at the solutions. The green ones I will be solving with the green pen, the blue questions with the blue pen, and the red questions with the red pen. So you can fast forward to the relevant section that you need. First we looked at 10 take away 6. You could use a bead string for this. There's 10 beads, take away 6. 1, 2, 3, 4, 5, 6. And there are 4 left. 1, 2, 3, 4. Number 2. 6 plus something equals 10. Now if 10 take away 6 is 4, then 6 add 4 must equal 10. We can see that with the diagram. If our large number is 10, and our parts that make up that number are 6 and 4, then if 10 take away 6 is 4, then 4 add 6 is 10. You can also see that with coins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can split these into 6 and 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So if 10 take away 6 is 4, then 4 add 6 is 10. Number 3. Something add 6 is 10. That something is a 4. So notice this fact, 4 add 6 is 10, also tells us other facts like 6 add 4 is 10 and 10 take away 6 is 4. Also 10 take away 4 will be 6. 10 take away 2. You could use 10 beads, take away 2, and we have 1, 2, 3, 4, 5, 6, 7, 8 left. You could also see that with the coins. And you can also see that with the diagram. You might also know the answer if you learn your number bonds. Number 5. 20 take away 12. Let's look at 20 take away 12. There's 20. We take away 12 by taking away 10 and then 2. And we're left with 8. 1, 2, 3, 4, 5, 6, 7, 8. Notice that's the same answer as when we did 10 take away 2. Because really, we only need to look at this 10 and take 2 off that 10. 20 take away 2, however, means that we are left with 18. Again, notice the similarity. 10 take away 2 is 8, but if we had 20 to start with and we need to take away 2, then we have an extra 10 in our answer. Blue section. 100 take away 64. Because it has zeros, column subtraction will be a little bit more difficult than a number line, so it's better to use a number line. And we're taking away a relatively large number compared to the number we started with, so it's going to be better to count on. We start at 64. We use our number bonds to add on to the next 10. We use our number bonds to add up to the next 100. And the answer is 36. You could use a bead string to see this as well. We have 100 beads. We're going to start at 64. 10, 20, 30, 40, 50, 60, 1, 2, 3, 4. We add on 6 to bring us up to 70, and then we add on 30 to take us to 100. Notice the similarity between adding and subtracting. We can solve a subtraction question by adding on, because adding and subtracting are the opposites. In other words, if 100 take away 64 is 36, then 36 add 64 is 100. Also, out of interest, 100 take away 36 will be 64. Start with 100, take away 36, you get to 64. So because adding is the opposite to subtracting, you can actually use adding to solve subtraction questions. So number 7 was 36. And we've just seen, therefore, that the answer to number 8 must be 36. You can also see this in a diagram very clearly, a part-part whole diagram. If we write the largest number in the top bar, and we split that into two parts, 36 and 64. 36 and 64 is 100, so 100 take away 64 is 36, and 100 take away 36 is 64. So number 9, 64 add 36 is 100. Number 10. 100 take away 22. Again, we can use a number line. You can count forwards or backwards for this. I'm going to count on because I find that easier. Add 8, bring us up to 30. Add 70 to take us to 100. And the answer is 78. Number 11. 1,000 take away 220. Notice the similarity between these two questions. So we can adapt this diagram. Instead of having 100, we have 1,000. And we're starting at 220. And this time we're going to add up to 300 by adding on 80 and then adding on 700. So everything in this question is 10 times bigger than the question above, including the answer. 780. Number 12. 1,000 take away 222. Again, this is very, very similar to the previous questions. We can actually use this answer to work this one out. Because if we've taken away 220 and we get to the answer 780, then we just need to take another 2 away. So the answer will be 778. Let me show you what I mean. 1,000 take away 220 is 780. Then if we take away 222, we're just taking away 2 more, which is 778. So quite often you can use information from questions you've already done to help you solve the answer. If you're going to solve this from scratch using a number line, it would look like this. You would start at 222. You would have to add 8 to give you 230. Then you would add 70 to give you 300. And then you would add 700 to give you 1,000. And the answer is 778. 102 take away 4. You could use a column method for this. It wouldn't be that hard, but you would have to exchange over several columns. It's easier just to do this one in your head. You could just take away 2 and then take away another 2, and the answer is 98. To help you visualize that, we'll draw a number line. And because we're taking away a small number this time, I'm going to count back instead of counting on. You can solve it by counting on. You'd start at 4, then you'd add 6 to give you 10, and then you'd add 90 to give you 100, and then you'd add 2 to give 102. But that had more steps than when we counted backwards for that example. So it depends what the question is as to whether you count forwards or count backwards, although you can get the right answer doing it both ways. But often one is quicker than the other. Number 14, 1002 take away 4. Notice the similarity with the question above. We're just going to take away 2 and then take away 2 again, and we're going to use our number bonds, and we end up with 998. If you want to see that on a diagram, we've got 1002. We take away 2 to give us 1000, and then we take away 2 from 1000 and we use our number bonds. Number 15, 1020 take away 40. Again, very similar to the question above, except these digits have now turned into tens. So we would just take away 20 and then another 20, and we get the answer 980. On the number line, 1020, take away 20 is 1000, take away 20 is 980. Number 16, 1020 take away something is 40. So we can use the information from the question above. That must be 980. We can show this in a diagram. If our large number is 1020, and that's been split into two parts, where one part is 40 and the other part is 980. 40 add 980 is 1020. 1020 take away 980 is 40, and 1020 take away 40 is 980. So that answers question 17 for us as well. What do you add to 40 to give you 1020? And the answer is 980. Final question, number 18. 9006 take away 18. So we've increased the level of difficulty here by taking away a 2-digit number instead of a 1-digit number, but the principle is the same. We start with 9006. Let's take away the ones first. We'll take away 6 to give us 9000. Then we take away another 2, so that we've taken away 8 altogether, and that gives us 8,998. Now we can take away a 10, just by taking it from the tens column. And we're left with 8,988. So today you've seen lots of interesting methods. Particularly, you've looked at number lines, and sometimes we count on from a number and sometimes we count back. And sometimes we don't use a number line at all. Sometimes we might use a column method. So you're probably wondering, when is it best to use each method? Well, I've got some guidelines for you which will help you. Typically, I would say, if the numbers in your question don't have zeros in them, then I would use the column method, because you probably don't have to do very much exchanging and it could be very straightforward like this. But if your starting numbers have zeros in them, then I would definitely use a number line for that, because otherwise the exchanging is going to be very complicated when you're using columns. If you're using a number line and taking away a big number compared to the one you started with, then I would definitely count on because you have a smaller number of jumps. But if you are taking away a relatively small number compared to the one you started with, then I would count backwards because that will give you the small number of jumps. So in a nutshell, if you've not got zeros, I would use a column method. And if you have got zeros, then I would count on if I'm taking away a big number, and I would count backwards if I'm taking away a small number. So now I've got a little challenge to finish today. I'm going to give you 3 questions, and each of them lends themselves to a different method, either taking away in columns, or taking away on a number line by counting on, or taking away on a number line by counting backwards. Have a look at the questions, try to decide which method is going to be the most appropriate for each of the questions, have a go at them, then hit play, and we'll see if your solutions are similar to mine. Meanwhile, I'll have a comedy pause for thought moment, so hit pause, have a go, answering the questions. When you're done, hit play, and we'll carry on. Okay, let's see if you tackled them in the same way that I did. The first question I definitely would have done with column subtraction. There's no zeros in the answer. In fact, you don't even have to exchange any numbers. It just comes out very easily at 532. The second question, 100 take away 76, I would use a number line for that because there's zeros in the bigger number, 100. And I would count on because you're taking away a relatively large number, so counting on will have a small number of jumps. So here you would start at 76, add on 4 to give you 80, add on 20 to give you 100. The final question, 1002, take away 6, I would use a number line, but I would count backwards. I'd use a number line because there's zeros in the number that I'm starting with, and I'm only taking away a small number, so counting backwards will give me a small number of jumps. So I'll just take away 2 to give me 1000, take away 4, and end up with 996. It should also be mentioned here that the number line method really is just to help you to picture what you're trying to do in your head. So when you're learning how to calculate in your head, it's very useful to draw the number line and see it. But after a while, you won't need to draw the number line. So parents watching this might think, well, it's a very long method compared to the column addition. The point is, you're not going to use it as a written method in the end. You're going to actually be able to do this in your head by holding the numbers in your head and visualizing the number line. So the number line is like having stabilizers when you're learning how to ride a bike. They will give you the support that you need to begin with to understand what you're doing, but then after a while you can remove them and do it without. So that's it for me this week. Over the Easter holiday, I'm actually going to be putting out some videos for parents. So parents are going to be showing you how to do the 4 calculation methods, addition, subtraction, multiplying and dividing. I'm going to be showing you the written algorithms that you probably learnt in school, and many of you may have forgotten because you've never used them since. But also I'm going to be showing you some very useful hints and tips of how you can help your child to understand those, and that's the really important part. So if you want to help your children effectively at home with calculation, then these videos coming up over at Easter are very, very important for the parents. After Easter, I'm going to start putting out some more lessons for children every day, and we're going to be looking at the calculation methods, written calculation. We're also going to be looking at problem solving, and then the week after that, we're going on to fractions, decimals, percentage, and that kind of thing. So lots more of really important stuff to come, but have a good Easter holiday, and parents, watch out for those videos. So the next few are going to be for you.